Assalamu alaikum dear students, welcome to the lecture of the waves oscillations. In this lecture we will discuss about the harmonic oscillation in two dimensions. So what will be in this we will discuss what are the resultant motions when two harmonic waves interfere. If they have the same frequencies, then what will be their resultant waves, and if those two interfering waves have different frequencies, then what is the resultant motion of their interference. So let consider two simple harmonic motion of the same frequencies. First we will consider the two wave of the same frequencies having omega frequency but having displacement perpendicular direction, because we are considering that our the equation of motion is in two dimensions, acts simultaneously on a particle. The equation of motion along x-axis is equal to a sine of omega t plus alpha 1, and for second we have motion along y-axis which is equal to y is equal to b sine omega t plus alpha 2. So the question is, find the resultant motion for the various value of the phase difference. So what will be the resultant motions if the phase difference between these motions are changed? So first we will solve these equations, and first our task will be to get a resultant equation. Then we will play with the different values of the alpha 1 and alpha 2 and explain for the various result. So first we can write these equations. If we divide a on the both side of this equation, so this will be written as x over a is equal to sine omega t plus alpha 1 if we divide this a on the left hand side. So this is x over a, and we can evaluate this expression sine omega t plus alpha 1. This can be written using trigonometric identity, sine alpha and cos alpha, and it's similar sine omega t cos alpha 1 plus cos omega t and sine alpha 1. Similarly, dividing b on the other side, so we will get y over b which will be equal to sine omega t plus alpha 2. We can evaluate using the same method as in the first, sine omega t plus cos alpha t. So if we use the trigonometric identity for this, so sine omega t cos alpha t 2 plus cos omega t and sine alpha 2. So we have done nothing but evaluate this sine identity, sine alpha plus beta. So the next step is, this is, for example, this is equation 1 and this is equation 2. For example, if we see that this equation contain sine alpha 1 and this equation contains sine alpha 2, so we need to multiply this first equation with sine alpha 2 and the second equation with sine alpha 1 if we want to evaluate some for some result. So the first thing, we will multiply this equation with sine alpha 2 and this equation with sine alpha 1, and subtracting the second equation from the first equation. So what we will get, if we multiply this equation with sine alpha 2, so x over a sine alpha 2, then we have to subtract from this equation after multiplication by sine alpha 1. If we multiply this equation sine alpha 1 and then subtracting, we are multiplying and subtracting in the one step. So please note that x over a sine alpha 2 from the left hand side minus sine alpha 2 and multiply by this, and we have obtained this result. Now on the right hand side, if we multiply with sine alpha 2 and if with this sine alpha 1 and subtracting this equation, we will get sine omega t sine of alpha t2 minus alpha 1. So we have taken sine omega t common, and the rest of these formulas for sine alpha t2 minus alpha 1. Similarly, if we multiply this equation with cos alpha 2 and this equation with cos alpha 1 and again subtracting these equation, so we will have x over a cos alpha 2 minus this equation y over b sine cos of alpha 1, because we have to multiply this equation with cos of alpha 1. This equation already contains cos alpha 2. So again taking common cos alpha 2 and sine alpha 1 minus this is the right hand side, because after multiplying this equation with cos alpha 2 and this equation with cos alpha 1. So we have obtained two equations, the first one and the second one, and both operations are mentioned here. First we have multiplied sin alpha 2 with this equations, and then sin alpha 1 with this equation, then we have subtracted these equations. And in the second step we have multiplied cos alpha 2 with the first equation and cos alpha 1 with the second equation and subtracted them. We have obtained two equations. Now our task is to solve these equations. If we take square of these two equations and add, we will take square of these equations individual and then adding. So what will obtain if we take the square x square over a square, here x square over a square, x square over a square will become common, and sin square a2 plus cos square a2 will become 1. Similarly y square over b square and y square over b square, so y square over b square and y square over b square will become common, and sin square a2 and sin cos square alpha 1 will be become 1. And another term will be cross product term, because when we expand the square of these two terms, so we will have a square plus b square minus 2ab. So the product term will be from the both two equations, that it will be minus 2xy over ab cos of alpha 1 minus alpha 2. And similarly on the right hand side, sin square alpha 2 minus sin square alpha 1 minus alpha 2, the negative sign will become positive because of the square. So sin square a2 alpha 1 minus alpha 2 and will become common, and sin square omega 2 plus cos square omega 2 t will become identities. So we have to just take square on the right hand side and add these two equations, and similarly taking square on the left hand side of these two equations and add. So we will get this x square over a square plus y square over b square minus 2xy over ab cos of alpha 1 minus alpha 2 and this equation. So next, now if we look that this resultant equation can be changed. If alpha 1 minus alpha 2 is equal to even multiple of pi, means 0, 2 pi, 4 pi, then this will become 1 and this will become 0. So our equation become x square over a square plus y square over b square minus 2xy over ab. So this factor will become x square over a square plus y square over b square minus 2xy over ab, because this will become identity, because alpha for even multiple of pi means 0 pi, 2 pi, 4 pi, this will cos of alpha 1 minus cos alpha 2 will become identity, and sin square this will become 0 for even multiple, sin pi, sin 2 pi, sin 4 pi, this will become 0, and this will become cos of alpha 1 cos of alpha 2, this will become 0. This will become 1 and this will become 0 for even multiple of pi. So we will left with x square over a square plus y square over b square minus 2xy over ab is equal to 0. So this we can write this equation with like this: x square over x over a plus y over b whole square. If we erase this term, x over a plus y over b and whole square, because this will become 1 and this will become 0 for even multiple of pi, 0, 2 pi, 4 pi and 6 pi and so on. So we can here we will have with the negative sign, because we have minus 2xy here, so we will have minus y over b. So if we solve this equation, this will give us y is equal to a over b and x. So if we compare this equation with the equation of line y is equal to mx, so this will become slope, and this is x, y is equal to mx, so this will give us a straight line as shown in the figure. So this will become a straight line y is equal to mx. So our resultant equation will be along the lines. Similarly, for odd multiple, we will have this with the cos of alpha 1 minus cos of alpha 2 will become minus 1. For odd multiple of pi means 0 pi, I mean 3 pi, pi and 5 pi and 7 pi, this will become minus 1. So here minus 1 and minus 1 become plus 1, and here we will have plus x over a plus y over b, and we will have negative sign, and on the right hand side for even multiple or odd multiple, sign of alpha 1 minus alpha 2 is always 0. So we will get y is equal to minus alpha over beta into x. So again we will have a straight line, but now in the second and the fourth quadrant. So our slope will be negative in the second case. Now let's go and evaluate for the another angles. This is for the positive and this is for the negative. For odd multiple pi, 3 pi and 5 pi, we will have a negative slope. If we see for angle pi over 2, 3 pi over 2, 5 pi over 2, then our resultant equation will become, then this equation, if I erase this, for if we alpha 1 minus alpha 2 is equal to pi over 2, so cos pi over 2 is equal to 0, and sine square alpha 1 minus alpha 2 is pi over 2. For allied angle, this will become 1 and this will become 0. So if this term will become 0, it means x square over a square plus y square over b square is equal to 1. So this is nothing but equation of a circle. So our path will be long, like a circular path. If this a over b is equal to 0, it means this will be circle. If a or b are not equal to 0, it means this will be not a circle. If our angle become delta is equal to pi over 4, mean alpha 1 minus alpha 2, mean the angle between two, the resultant motion angle between the two interference wave is pi over 4, 7 pi over 4, 9 pi over 4 or 15 pi over 4. Our equation will become x square over a square plus y square over b square minus, because for pi over 4 it will become under root 2 xy over ab, and which will be equal to on the right hand side 1 over 2, because for this angle sine square is equal to 1 over 2, because when we put these number in this functions, in this will give us 1 over 2. Alpha 1 minus alpha 2 is equal to, if we put pi over 4 and 5 pi over 4 and 3 pi over 4, this will give us 1 over 2 as in this. So our the right side we will have a 1 over 2. So if we solve for this equation, this is equation of ellipse, so we will get the oblique ellipse for this angle, like this or either in this. So this is the resultant equation, the resultant motion when two periodic waves interfere. Now we have assumed that both interfering waves have the same frequency. If these waves have not the same frequency, then we will have, in this case, when there is no phase angle between delta is equal to 0, it means we have a straight line. When the angle is pi over 4, we will get ellipse. When pi over 2, we will have the circle. When 3 pi over 4, we will have again ellipse, and left hand ellipse and right hand ellipse. Similarly for pi and for various angle, we have obtained different result. Okay, now if the angle if the frequency between the two waves, interfering waves, are not same, means omega x and omega y are not same, then the resultant motion is called Lissajous figure, and Lissajous figure we will discuss this topic in the next lectures. So I will stop at this point and we will again start from these points.